Here we have a problem on intermediate value theorem. Okay, let's go with the information. Use the intermediate value theorem to show that there is a root of the given equation in the specified interval. Okay, there is an equation given over here. There is x to the fourth power positive x negative 3 equals to 0, and the interval is 1, 2. Okay, to use the intermediate value theorem, what I need to do is first I have to get a function from the given equation. For that, we have to make sure that we have 0 on the right side of the given equation. In the given equation, we have 0 on the right side. So if it is not so, first we have to make the right side of the given equation as 0. So once we make the right side of the given equation as 0, so now we have to assign a function f of x for the expression we have on the left side. That is f of x equals to x to the fourth power positive x negative 3. Okay, now let me assume there is a root x equals to c for the given equation over here. Since x equals to c is one of the roots for the given equation, then I plug in x equals to c into the function over here, then f of c must be equals to 0. And also here we have an open interval. So when I want to check whether intermediate value theorem applies for a particular function, so I have to write the given open interval as closed interval, that is 1, 2. So when I write the given open interval as closed interval, we have to understand, so we can include these two values 1 and 2 also for x, and also all the middle values all the values between 1 and 2. Okay, now to check whether intermediate value theorem applies for this function, so I have to make sure the function is continuous over the closed interval 1, 2. Since it's a polynomial function, it's continuous for all real value of x, so it is continuous. F of x is continuous for all the values of x in the closed interval 1, 2. So the first condition is satisfied. Okay, now the second condition, what we need to do is I have to find the value of f of x at the boundary values of the closed intervals. That means I have to find the value of f of x at x equals to 1 and x equals to 2. Okay, first let me get the value of f of 1. That is, I'm going to plug in x equals to 1, the left side boundary value for x, into the function over here. Then I'm getting 1 to the fourth power positive 1 negative 3. So 1 to the fourth power is just 1, positive 1 negative 3. So 1 positive 1 is 2, 2 negative 3 will become negative 1. Okay, now let me plug in the other boundary value 2 for x into the given function. Then I'm getting f of 2 equals to 2 to the fourth power positive 2 negative 3. So the evaluation of 2 to the fourth power is 16 positive 2 negative 3. So 16 positive 2 is 18, 18 negative 3 is 15. Okay, so now I got the values of f of x, the boundary values are 1 and 2. So already we have the value for f of c, that is 0. So the value of f of c must be between the two values of f of x we got over here. So the value we have for f of c, that is 0, is between negative 1 and 15. So then we can write the inequality, that is f of 1 less than f of c less than f of 2. So because the value of f of c is between the values of f of 1 and f of 2, so the second condition is also satisfied. So the intermediate value theorem applies for this function. So there is a root for the given equation over the specified interval 1, 2.